This is part of lesson 8C1. The definition for this example is working with logically equivalent. Two propositions are logically equivalent if the two columns are exactly the same in a truth table. So I'm going to scroll down in this example in just a minute. I just want you to highlight again the definition for logically equivalent is when two propositions have the same truth table columns. And we're going to do this example 8 on the next slide. So if we look at this example, it's asking you to do a truth table for this symbol, and the final product is right here in the green. And then this symbol set has the final green column. And notice that these two are exactly the same. They have the same truth values, false, true, true, true. So these are considered logically equivalent. So I'm going to go on to the next slide, and we're going to create the truth values for this, example 8. All right, so here's example 8. We're going to start off with proposition P. So remember from our previous video, it's true, true, false, false. And then proposition Q is true, false, true, false. You always set up your proposition P and Q with that pattern. All right, here we go. We're going to start off by doing this piece. Remember that symbol has the word and in it. So this is P and Q. So we're looking at column 1 and column 2. So I'm going to go back to our definitions right here. Notice our symbol is a conjunction. We're looking for true only when both are true. So the first row, we have a true and a true. So that's true. We have a true and a false. Both of them aren't false, so this is a false. False and a true. Both of them aren't true, so it's a false. We have a false and a false, so it's a false. All right. Now we want to negate that third column. So negate P and Q. So we go to the previous column, which had the conjunction and we're going to do the opposite. So if this is true, this would be false. If this is false, the opposite is true. This is false, so this is true. This is false, so it is true. So we're done with that piece. Now I'm going to come over to my second set of symbols. And we have a not P. So I go to my first column, and we're going to negate them. So opposite of true is false. Opposite is true is false. Opposite of false is true. Opposite of false is, whoa. Alrighty, opposite of false, oh my gosh, true. Something's going on there. All right, now we're going to negate Q. I don't know why that's coming up over there. Opposite of Q. So we're negating Q. So opposite of true is false. Opposite of false is true. Opposite of true is false. Opposite of false is true. All right, I'm going to erase this. Now it's saying not P or not Q. Remember that symbol there is the word or. it is a disjunction. Not P or not Q. So we go back to disjunction. Right here. True only when one or both are true. False if both are false. All right, so we're looking at the columns in the blue right here, not P or not Q. So this is false and this is false, so the rule says it's false. This is false and this is true. We only need one of them to be true, so it's true. One of them is true and one of them is true, so we're good. We can have one or both of them be true, so we're good to go. All right, now we're going to look at this column in the green, final answer, and this column in the blue, final answer. Are they the same? Are they logically equivalent? Well, we have false, true, true, and true. So these are considered logically equivalent. They are the same. I'll try to extend the page here. So how you can write that, so logically equivalent, they mean the same thing. Not P and Q is the same as not P or not Q. They're equal to each other.